Today we're going to talk about logarithms. We're going to review x-intercept, increasing and decreasing, and domain and range. So we start with our exponent because logarithms are another way of expressing exponents. So a being our base, a to the power of x, x being our exponent, equals y, our argument or our answer. So to change that into a log, we do log base a, the a's are still our bases, of y equals x. So just to remember, your base is a, and your exponent is x. So one of those important rules about logarithms is that your base, your b, will never be a 0 and it will never be a negative number. Look at the three graphs below. See if you can find anything that they have in common. If you guess that all the x-intercepts were the same, or that you saw that they seem to all have the same point on the x-intercept, which would mean that all the x-intercepts are the same, you would be correct. Remember, with x-intercept, the one thing we always know is that the y value is always 0. So the y value is always 0. The x has a number, but the y value is always 0. So on all three of these examples, they all had the exact same 1, 1, 0, and that's the x-intercept. So just to prove that all of them had the exact same x-intercept, let's take a couple of them and rewrite them as exponentials, functions, and solve for them. So remember, we know that the y value, if it's an x-intercept, we know that the y value is 0. So even if we didn't know what the x value was, we know that the y value is 0. So we can plug in a 0 for the y value. So when we rewrite, let's say the example, the second one, so we have e to the y power equals x. Well, we already know that for the x-intercept, the y has to be 0. So if the y is 0, then we plug in e to the 0 power equals 1. We know anything to the 0 power is 1. So then we would plug in 1 for the x. And the same thing would go with y equals log of 2x. We could rewrite it as 2y equals x. And once again, we know that the y value has to be 0. So we plug in, we replace that y value with a 0. And we would have 2 to the power of 0, and we know that 2 to the power of 0 is 1. So our x value is 1. So it really doesn't matter what your base is. When anything raised to the 0 power, it will always be 1. So each one of those all have the same exact x-intercept, 1, 0. So let's try a couple on our own. So the first one is log 5 of x equals y. So remember, if you're trying to find the x-intercept, the one thing that you'll want to remember is we're looking for the x value in our point, but we know that the y value is 0. So we will end up plugging in 0 for y. So take a moment and see if you can figure out how it's rewritten. Now that you've tried, let's rewrite it. So we would have 5 to the y power equals x. And then we know that we're going to replace that 5, or that y, with a 0. So we would have 5, 0. And we know that 5 to the 0 power equals 1. So once again, our x-intercept would be 1, 0. X equals 1, y equals 0. Let's try one more. Log 3 of x equals f of x. Now remember, go back to your algebra. When we see f of x, we know that that's the same thing as y. Okay? So just remember if we've forgotten. So take a moment and rewrite it. 3 y equals x. And you should start seeing the pattern by now. So you know that we're going to replace, we're still looking for those x-intercepts. So we're going to replace that y value with a 0. And we know anything to the 0 power is 1. So once again, this x-intercept would also be 1, 0. So now you're able to find the x-intercept for these type of logarithms. So let's talk about increasing and decreasing logarithmic functions. So we read our graphs left to right. So let's start with the black function, the black line. And as we're reading left to right, we notice that it is decreasing as we read across. So it's a decreasing function. Now, if you look at the red line, as you're reading across left to right, we notice that the line is going up. It is increasing. So it's an increasing function. So the one thing, if you're looking at a graph, it is visually, it's a little bit easier to tell if they're increasing and decreasing, reading left to right. And I'll also, we'll talk about if we just see the function written out. Now, if we have the function written out, to know it's increasing and we're reading it left to right, we can see that the first graph, f of x equals log 10x, is increasing. However, if we just had the f of x, log base 10x, another way of knowing is that b, our base, is greater than 0. So if we look at that base and it's a 10, we know it's greater than 0, so it's increasing. And if it is decreasing, if we didn't have the graph, if you haven't plugged it in your calculator, you can look at the equation and see that it is 0.5. So our base is between 0 and 1. So if our base is between 0 and 1, then we know it is a decreasing function. So if you see a graph or you see the equation, you'll be able to tell if it's an increasing or decreasing function. So let's try these. Look at the red line. Determine if the red line is increasing or decreasing. If you chose increasing, you'd be correct. As you read it left to right, you will see that it is going up, so it is increasing. So now let's look at the blue line. Is the blue line decreasing or increasing? If you are reading it left to right, you notice that the blue line is going down, so it is decreasing. Another question would be, if you saw a function and it had a base of, and I just gave it to you, a base of 1/4. Would that be an increasing function or a decreasing function? You are right. It is a decreasing function because it is between 0 and 1. So it is a decreasing function. So you can determine increasing and decreasing by looking at the equation or looking at a graph. let's talk about domain and range of logs. Now remember, if the log doesn't have the b it's showing, then it's 10. So this one's y equals log x, which would be log base 10x. So let's rewrite that in exponential function, just so we can kind of get an idea about domain and range. So that would be 10y equals x. So what happens to this x? Because we need to know all about our x's and y's when we're talking about domain and range. So if the x gets larger, like we have it at 1, what would the y be? So it would be 10 to what power equals 1? Well, we know that to equal 1, we have to have to the power of 0, which we've already learned that. And right there, we know that that's the x-intercept too, because we've learned that already. So then we go to, if we put in 10 to the y power equals 10. Well, for 10 to equal 10, what power do we have? We know that that's 1. And then we do 10 to what power equals 1,000? Well, we know that that would be 3. So we notice that as x gets larger, y is increasing as well. So now let's look at if x got smaller. And x just keeps getting larger, and we already know that our base, our b, has to be positive as well. So on the last slide, we talked about x getting larger. Now let's talk about x getting smaller. So we have 10 to the power of y equals x. Well, if x is 0.1, it's getting smaller now, then what power does y have to be? So it would end up being correct, -1. And we can put that in our calculator. And then we can try 10 to what power equals 0.001. Well, that would be 10 to the -3, because we know powers of 10 are a little bit easier to work with. But we can see how now the y values are becoming negative. So it's going down. And then 10 to what power equals 0.000001. And that would be -6. 6 places to the right of the decimal. So as we see, the x value is getting smaller and the y value are now going to the negatives, but the x value is still positive. So what does that tell us about domain and range? So the question becomes, can the x value ever be 0? Because remember, the x value, that's your domain. Can the x value ever be 0? So that would be log of 0 equals y, or an exponential 10y equals 0. No, that can never happen. So 10, we can't raise it to any power to make it 0. So x can never be 0. And now knowing that x can't be 0 and your base is always positive, here's a graph of an exponential function. And remember, your domain is all x values from left to right. So if you were doing the domain, we know that it comes really, really close, like the 0.000001 for the x that we plugged in, but it's never gonna hit 0. So when we're reading this graph, left to right, we know that the domain will start at 0, but will never hit 0. So it can't equal 0. And then we keep going to the left, and it just continues to go on forever. So we know that that's infinity. Another way of writing this is parentheses 0, comma, infinity. And with the domain and range, you'll see with all of the functions that we've done today, they'll be the same. So let's look at the range. So the range on this is all possible y values. So bottom to top, we see that it continues and can continue down forever, so we know that's negative infinity. Less than, because because it can't equal infinity, the y values, less than. And then as we go to the top, as we go up, we go to the top. The arrows tell us that it continues on forever. So once again, that will be infinity. So our range is, another way of writing it, parentheses, negative infinity, comma, infinity. And that would be our domain and range for this log function. So this one is as an equation. If you want to graph it on a calculator, please do so. I always love pictures and graphs. They're very visual. You can always build a table if you want to as well. It will be the same as the other ones where we already know that the base is positive and it's bigger than 1. So we know it's increasing and it's positive. So it'll go to infinity. And we've already determined that the x value can't be 0. We'll get really, really close, but we'll never be 0. So we know that the domain, our x values, are 0 to infinity. And the range stays the same, negative infinity to positive infinity. So let's try everything we've learned today with this graph. First, let's ask ourselves, is this graph increasing or decreasing? You can look at the line itself on the graph, reading it left to right. Is it going up or is it going down? And we see that this one is going up. So we know that this graph is increasing. How else can we figure that out? We can look right here at the base. The base is 2. We've already determined if the base, we know that the base will be positive, and if the base is bigger than 1, it will be increasing. So now let's ask ourselves about the x-intercept. We do remember that the x-intercept, the y value has to be, that's right, 0. So when we plug that in, we determine that it is, the x value is 1. We can look at the graph or we can plug it into the equation and build a table. And we see it right here. So once again, 1, 0 is our x-intercept. Now let's go to domain and range. Same domain and range that we've been working with. The domain. We know that it can get very close, but it can't touch the what? That's right, the 0. So it will start at 0, be less than an x, less than, and it keeps going on and on forever. So it's infinity, positive infinity. And remember, you can always write that as 0, comma, infinity. Now going for the range. The range doesn't change. We go bottom to top. So at the bottom, it keeps going on forever, so that's got to be negative infinity. Less than or the y value, because we're talking about range, less than positive infinity because it continues on forever. Remember, you can always rewrite that as in parentheses, negative infinity, comma, infinity. Have a great day.